Hey, what's going on, guys? I'm going to be working a quick calculus problem for you guys involving rates of change. So without further ado, let's read this problem and get into it. So a man starts walking north at 4 feet per second from a point P. 5 minutes later, a woman starts walking south at 7 feet per second from a point that is 500 feet due east of point P. At what rate are the people moving apart 15 minutes after the woman starts walking? Alright, first things first, we want to visualize what's going on, so we want to draw this out. We can start with our point P. And the man travels north of point P, so that's just, as you guys know, straight up. And the woman walks south, but she doesn't walk south from point P. She walks south from a point that is 500 feet east or to the right of point P. So we can go ahead and plot that point right here. And she travels south. The distance between these 2 points, as stated in the problem, is 500 feet. Alright, so we can label the man's journey X, woman's journey Y, and let's connect their current locations. So now we're left with this bizarre picture, but we can add some lines down here and turn this into a giant right triangle. Base of this right triangle is going to be 500 feet due to it being parallel with the line that connects point P and our unnamed point. And let's see, to make this a little easier, I will go ahead and just draw a right triangle for you guys. Right, again, we said 500 feet was the base, and we'll call our hypotenuse, we'll call that point Z. And our long end, we're going to call X plus Y. This is because on our first graph or sketch, the long end is made of our X and is made of our Y. So just X plus Y to make this long end. Alright, so we want a formula that's going to connect our X, Y's, and Z's. So we can use the basic geometry formula, which is going to be a squared plus b squared equals c squared. We're going to want to plug in x plus y for our a, 500 for our b, and z for our c, which is going to give us x plus y squared plus 500 squared is equal to z squared. Alright, so we're not looking for a distance. If we were, z would be what we'd look for, but we're looking for a distance with respect to time or a rate. So we want to find a distance z with respect to time. So to do that, we're going to have to take the derivative of the entire equation. So the derivative of x plus y squared is going to be 2x plus y, and then times dx with respect to time plus dy with respect to time. The derivative of 500 squared is going to be 0, so we don't have to put anything for that. And the derivative of 2z squared, or z squared, is going to be 2z, and then times dz over dt. Sorry, the pin's being a little weird. Alright, so we want this. We want dz dt. So we're going to cancel these 2's out because we can, and we're going to want to get dz dt by itself, so we're going to divide both sides by z, which in turn will give us x plus y over z times dx over dt plus dy over dt dz over dt. Alright, so we have everything where we want it, so now we want to go ahead and start plugging stuff in. And the way we're going to do that is we're going to put 4 for our dx dt and 7 for our dy dt, because we said the man's journey was x, he travels at a rate of 4 feet per second, so you know that is our distance with respect to time. And same for our woman. So we can go ahead and plug 4 and 7 in to dx dt. 4 plus 7 dz dt. Alright, so now we want to find our x and our y. And how we're going to do this is we're going to take our rates. So for example, to find our x, we want to take our rate 4 feet per second, and we want to get rid of the second. So how we're going to do that is take the total amount of time the man walked, which is 20 minutes total. So 20 minutes, and we want to convert that to seconds, so the seconds cancel out, so we could just multiply by 60. So the minutes are gone, and we can get rid of our seconds. So that's going to be our x, and it's going to be the same with our y, but we have to be careful because the total amount of time the woman walked is different. She walked only 15 minutes. And again, we're just going to multiply by 60, so all that cancels out. So our x is going to, in turn, be 4,800, and our y is going to be 6,300. Alright, so now we want to find our z. So how we're going to do that, are we going to plug these numbers into this original equation we wrote up here. So we're going to have 4,800 plus 6,300 squared plus 500 squared is equal to z squared. And we're looking for z, not z squared, so we can go ahead and take the square root of both sides before any of this is done. So when all this is worked out, we get z equals square root of 123,460,000, which is a big number, but everything will be alright. Alright, so now that we have our x, y, z, and our rates, we can plug all this back into this original equation we came up with. Alright, so x, 4,800 plus 6,300 over our enormous number, 123,460,000, and then multiplied by 7 plus 4, which is 11, and multiply the top by 11, and once you work everything out, you're going to get a number that is approximately 10.99 feet per second. So this should be your answer. This is what you plug into your answer box. And hope you guys learned something. Thanks for tuning in.